Hi, Paul.
Hey, how's it going?
Fine, you?
I'm doing pretty good. Let me go ahead and share my screen here. Okay.
Okay, see you.
Okay, perfect. So hey everyone, my name is Paul Ruiz, and I'm a developer programs engineer on Firebase. So today we're going to talk about two tools, Flutter and Firebase, and how they can be used for rapid prototyping. Let me make sure that this is working. Sorry. Oops. Make sure I'm sharing the right thing here. There we go. Okay. So whether it's at a hackathon with only one weekend to build something presentable, or you have an idea for an app that you want to test out before really investing in it, a lot of us have been in a situation where we want to build something that gets the job done quickly. So during the normal prototype development process, developers plan out what their app should do and how it should function, research the feasibility of the idea, map out their architecture, pick their tools, and then build a clean and organized prototype, right? So yes and no. Some people stick to a very formal process, but when building out a quick prototype or proof of concept app, most of us, myself included, just want to open up an IDE and start coding, and then we'll kind of figure it out as we go along. So given this, I'm going to talk about the two tools that I had mentioned earlier, Flutter and Firebase. Both of these are easy to use and address different development problems. Flutter is for client-side development, and Firebase is for the backend. Both are designed to be easy to use and are well supported with content and documentation to make getting up and running as easy as possible. So while I wouldn't say this is necessarily a deep dive, this presentation is going to look at a lot of code and tools to hopefully be helpful in getting you started with Flutter and Firebase. So while it might seem like a lot up front, I can't stress enough that you don't need to memorize everything. So all of this code that I show in this presentation is going to be available later in slides that I'll put up on Twitter, or you can email me for them, or I'm going to send them to the organizers, all that kind of stuff. So what I hope to do with this talk is help you leave with a vocabulary to look into both these tools further when you're ready to use them. So with that, let's go ahead and get started. So first, let's talk about Flutter. It's a UI toolkit that uses the Dart programming language for building native apps for multiple platforms on top of C++ using this 2D engine called Skia. This is the same graphical engine that's used by Chrome, Android, and a few other platforms, and it's all within the single SDK. Since everything is built from a single code base, you can create your prototypes for multiple systems, such as Android or iOS, without requiring specific developer knowledge about each of the platforms. Flutter is also completely open sourced, so not only is Google working on it, but so are many members of the developer community. So rather than being walled off from the internal workings of the tool, you can dig into the code to see exactly how Flutter is doing what it's doing, as well as send your own pull request. So if you want to improve it, I think there's something around 18,000 contributions right now from just people all over the world. And that number keeps going up as more people are discovering the tool and trying it out and then wanting to improve it. So aside from Flutter being cross-platform, you're probably wondering when you should use it for rapid prototyping, especially since other tools exist that do similar things. So like most development decisions, the answer is basically, it depends. While Flutter isn't the only tool that can work cross-platform, it is designed from the ground up specifically for creating apps quickly. It's able to easily tie into device hardware using external plugins and packages that can be imported into your projects. And then it also uses widgets, which we'll dig into a little bit more soon, to create UI components programmatically rather than requiring something like a layout file or a storyboard. One other feature of Flutter that I just think is really valuable for rapid prototyping is hot reloading. So you don't need to restart your entire app to test small UI changes. So instead, UI changes will automatically be applied to your running app as you change various values. So following up on the "it depends" answer, there's also going to be times when Flutter isn't the right solution for you, and it's better to figure that out early in the development process. So for starters, games are a lot of fun to develop, but Flutter just isn't really at a point where you can make most types of games quick enough to call it a rapid prototype. You would still need to write a lot of components from scratch that other platforms currently give you out of the box. Additionally, calling native APIs directly just isn't really super easy. Normally, you would write native Kotlin or Swift code and then use platform channels to communicate back and forth to the native level through a bridging process. So while this isn't necessarily a deal breaker, it is more work than just throwing some UI together and then calling it good. The next thing to consider is audio support, or rather the lack thereof. While audio isn't supported by native widgets, there are third-party plugins out there that can provide this functionality, which then brings me to my next point. So while there's tons of plugins for Flutter, some third-party libraries that developers are just grown to love and rely on just aren't really available right now. So you'll have to weigh the necessity of things like that versus working with what Flutter has before deciding to use the tool. Fortunately, there's alternatives for most things, but we'll kind of dig into that more later as well. And then finally, Flutter doesn't really have support for additional form factors like watches, televisions, and cars. So right now, Flutter has very limited support for Wear OS, but no support for platforms like tvOS. So like we talked about already, one of the biggest draws for Flutter for rapid prototyping is that it's an easy-to-use tool for creating custom UIs. So the first part of this presentation is where this talk is going to get a little bit more technical, as I want to give an overview of some of the ways that Flutter can be used to build UIs. So when you're working with Flutter, everything is a widget, and all UI is described by widgets in a tree structure. So one key term that you'll see in Flutter documentation around this is aggressive composition, which essentially just means that aside from some very basic widgets, the widgets that you use in your app, either custom ones that you put together or that come built into the platform, are going to be made up of other smaller widgets. So you can think of them kind of like bricks where you just kind of put them together to build whatever you want. So while there's hundreds of widgets out there, I just want to go over a few of them at a high level to give you an idea of this fundamental part of Flutter. So as I'm sure a lot of you know, you can't really start with anything in software without Hello World. So let's take a look at this example to get an idea of how Flutter uses widgets to create a bare bones user interface. So all our apps use the main function as their entry point, and in there you can initialize various components and start your Flutter application. You can also see a center widget in this example, which will center your content in the middle of the device screen. Next up is the text widget that, as you can probably guess, is going to show some text. And this text widget also has a few properties that can be applied to it. So the first one is the string that will be displayed by the text widget. And the second is a named optional property, which in this case is text direction, that can be used to customize the widget. So all said and done, you'll end up with this stunning example of a beautiful, simple user interface that pretty much just does nothing. But it's a good example of just the basic parts of Flutter. So before we really get into how to use some actually useful widgets, I want to divert for a moment to touch on how Flutter can be used on multiple platforms. So we've all seen apps made with multi-platform tools where they just don't look quite right compared to the system standard UI, such as Android apps that look like they were designed for iOS. So what makes Flutter handy here is that it's able to tell what platform it's on, so you can apply the proper UI elements for your app based on the OS. So you can actually see a couple examples here on the screen where it's the same exact app running on iOS and Android, but they each look native to their respective platforms based off the UI widgets that are being used. So this functionality is available through the Dart.io package that can be imported into your apps. When the user's on iOS, the platform.isIOS flag will be true. If the user's on a different OS, then that flag will come back as false. You can also see that we're using a standard ternary statement here to expand the proper widget for whatever platform the user's on. After you've checked that flag, you can expand an iOS-specific Cupertino widget to have it look like a native component when on Apple devices. So for this example, we'll take a look at using an iOS-styled slider from that Cupertino package. You will need to make sure that you import the Cupertino Dart package into your app in order to have this styled widget available. If the user isn't on an iOS device, then you can just expand a regular slider as a part of the second option in the ternary operation. And then finally, you can see that both of these sliders have properties that can be set on them. While the base properties are the same in this kind of incomplete example, there are some differences in the components, such as a background color property that only applies to the regular slider. So you'll want to check the documentation or source code whenever you use a platform-specific component, just to make sure that you're setting the correct attributes rather than assuming they're always going to be the same. And then since that last slide, for the sake of space, use an incomplete code sample, I've included a complete sample for a single slider here for everyone. So the value for the slider is a double that is saved outside of the widget. The active and inactive colors are set for the material design version of the widget, and the onChange property is set to maintain state on the slider as it's used. So one thing to actually pay attention to here is that the onChange property, if it isn't set, then the slider is actually going to be grayed out and not usable. So that property is required in the sense that it has to be there for the slider to be useful. Like a lot of other things though in Flutter, this widget is relatively straightforward. but you will need to look through the source or documentation to understand why certain properties are needed and what they do. So the next component that I want to talk about is the list, since honestly, most apps are essentially just list and detail screens. There's actually a lot that you can do with lists, like setting them up for infinite scrolling, having items react to long presses, and adding various custom composite widgets that each do different things. So to keep everything simple for this example, we'll start by just looking at the code for a super basic list of generated text items with a little circle icon in front of them. So after that, we'll take a moment to look at adding swipe to dismiss, kind of like what you see in this demo image, where you can swipe left or right to archive or delete and what have you. So the first widget here is the scroll bar. While it's not a necessary widget, it does provide, as you can probably guess, a scroll bar on the side of the list so that users know how far along the data they are. After that is the actual list view widget, which provides the scrollable area that contains and controls the list items. This widget also has a collection of properties that can be set to customize the list. So here you can see that we're setting a padding at the top and bottom of the list, though the only really required property is the children array, which will house the items that exist inside of this list view. The next part of this component is where things get a little bit more interesting. So while you can include a simple list or array data structure of other widgets, there's also this great list.generate call that can loop a set number of times to create widgets for your list view. So in this case, we'll simply create 100 items that will be displayed in our app. Each of those 100 items will be made up of a single list tile widget, which implements the material design specifications for list items for you out of the box, and is generally used to display some text and a leading item, like an icon for each list item. And then, as you might expect, this list tile has its own properties. So the first one is this exclude semantics widget, which wraps a circle avatar. So what this will do is it'll display the index of the generated list as an icon at the start of the list item. And since it's wrapped by this exclude semantics widget, it's not going to be read by accessibility tools like screen readers and whatnot, meaning that it doesn't add a lot of noise for users that actually do need to use those tools. It is worth noting that this exclude semantics widget should be used really sparingly, and only when there's a very specific and beneficial reason to use it to get around those accessibility tools that'll be advantageous for the people that actually need those tools to be able to use your app. So the final part of the list tile widget that in our list view is probably the most simple, and it's just a single string and a text widget that represents the content of the list item. This is the same exact kind of text widget that we saw in our Hello World example. So while that wasn't very much code, it does create a simple list view for our Flutter apps. So I actually have that exact code running in this graphic, but I also modified it to include a swipe to dismiss feature like we talked about earlier. So we can talk about that next as we go forward. So the core of this functionality is, again, it's another widget, just like pretty much everything else in Flutter. But in this case, it's a dismissible widget. So what's nice about this is that we don't need to replace everything that's in our current list to make swipe to dismiss work. So the dismissible widget will take the list tile widget from the last section and add it as its own child. If we ran our app at this point, each item in the list view would be swipeable, and it would be removed from the list view UI if completely swiped off the screen. While optional, the background property does help a lot by letting users know when they are swiping away on an item by changing what appears behind the list item during the action. So in this case, I'm just adding a new container widget that sets the background color to this very light green color. You can also set a secondary background color if you want the user to see a different background when swiping from the left or the right. And I'm just going to go back a couple of slides just to show you. This is exactly what that swipe to dismiss looks like again. So that's that same light green, and you can see how it animates the item away and kind of shifts everything with it. So this is all just in the UI, though. There's nothing actually affecting the data structure on this, but we'll get to that in a little bit. One thing that is worth noting here, though, is that since the background property accepts any widget, you can actually do some kind of fun and interesting things in this area, like loading in an animated GIF for the list item's background. So while it doesn't necessarily mean you should, it is kind of fun when you're trying to play with things. So if you wanted to have videos in here or anything else that would also work, it's not going to be the most efficient, but if you have a very specific reason that you would want to do that for your apps, it is available as an option. But this also means that anywhere that you can accept a widget in Flutter, you can put any other widget. So people have done some really interesting things where they can rotate the entire app kind of I don't know what the angle would be, where it kind of just becomes a line and then it reflips over and it's completely opposite. And there's some other things you can do with that. So now that we've looked at what you can do with the background of a dismissible, let's get into a couple more properties. So the first one is key. This is a required property that needs a unique value to keep things in order while removing items from your list, as it interacts with the actual data structure driving the UI. So to keep things simple, you can usually just use Flutter's unique key class to assign a unique key to your dismissible list item. Finally, there's the onDismiss callback. While this isn't required by the dismissible, it is useful when you want to display something to your users to let them know that they've removed an item from your list. This is also where you would notify your backend that an item is removed if it's hosted remotely. That way it doesn't show back up for your users the next time that the app is opened. And then since they're fairly often the widgets that are actually used in list views, I wanted to wrap up our general discussion of widgets by briefly talking about the card's design pattern. Like most widgets in Flutter, this snippet is pretty lean. The size box means that each card will have a predefined height, and that size box will wrap a child card widget, which sets some general properties for the card, like the shape and basic behaviors. Next up is the child of that child, which in this case is an inkwell. The inkwell is kind of an interesting widget, as it's what the card uses to figure out interactive touch areas and when users are actually clicking on those cards, and like where on the card. You can also set a touch area color, such as the ripple effect in Android, by setting the splash and highlight color. So if you don't want these to show up, you can actually set the property, though, to this colors.transparent, and nothing will show up on the card when it's being touched. It's a little way to kind of override the material splash effect if you don't want to have that in your app. And then finally, that inkwell has its own child, which is the actual content of the card that the user is going to see. So in this example, it's a custom composite widget called Travel Destination Content. So despite the complexity of this widget that we've kind of abstracted away here, you can see that you can add any sort of widget that you would want into your cards. So kind of the same idea as when we put that GIF into the background of the dismissible list items. So overall, this snippet is just kind of a nice example, though, of how Flutter uses a hierarchy of widgets to build a UI for your users. Cool, so I know that was kind of a lot, and I've only covered like a small handful of widgets that are out there. But if you want to learn more, I would say definitely go to the Google Developers YouTube channel to find the Widgets of the Week videos, and then just check out the official widgets reference documentation at flutter.dev. So now that we've covered a handful of common widgets, I wanted to get into some stuff that's just a little bit more useful when it comes to learning the platform quickly and then creating some prototypes. So the first tool that's great for getting up and running quickly is the Flutter Gallery app. This app is entirely open sourced and available on GitHub, meaning that you can just kind of grab whatever functionality that you like out of it to throw into your prototypes. It goes over a collection of widgets that you can use for both Material and Cupertino, which is the iOS styling. And it has a lot of other useful features that you can kind of mess around with in this Playground app. So each widget section in the Gallery app includes a descriptor, and it can bring up the code that was used to create that that section. So each widget page also has an icon at the top that will take you directly to the official documentation for the widget that you're looking at. Additionally, there's a variety of tools that can show you how to do animations, media playback, or display each of the available stock colors in Flutter to help you get your app put together even faster. The Gallery app also includes case studies, so you can see how common features work together in a kind of big picture scenario, rather than just a bunch of one-off widgets. So you can see here that we have a staggered grid view, a hero animation, circular animations, different types in a single list, and just kind of a few other items here just in these images. So this is great when you're trying to put together a quick prototype, as you get examples of animations and interactive components out of the box, rather than spending a bunch of your time trying to figure out how to work through already solved problems from random blog posts online, Stack Overflow, or other documentation. But speaking of the documentation, as you've probably noticed, I've mentioned it a lot already. So I'm a big fan of what the Flutter team has already put together, especially since a lot of it isn't the standard "this component does something" sort of stuff. So one of the things that they have is the Flutter Cookbook, which is a documentation page containing various code samples or recipes for common tasks that you might want to do in Flutter. So this is just kind of a sample of what's there, but you can see that it's a lot of great content that you'll use in pretty much any app, such as animations, design elements, and networking. So the next thing to talk about, plugins, are essentially a fancy word for libraries or modules, and are kind of one of my favorite parts of Flutter. Because the development community is so active and passionate about the platform, they've created thousands of these open source plugins that you can use in your apps to easily accomplish tasks without having to reinvent the wheel. So you can actually find most of these plugins by using pub.dev, which is a site that was created by Google for searching through plugins and finding their documentation and source code. So with that, let's take a look at a few useful plugins and how to implement them. So while there's a ton of great third-party plugins out there, I figured we'd actually start with Google Maps, since it's honestly one of my favorites and my go-to whenever I want to display location information for my users. So in this section, we'll go over the code that I used to make this exact demo image. So Google Maps functionality is wrapped by a Google Map widget that can be displayed on the screen. This widget has the bulk of its functionality handled by the onMapCreated method. If you're not familiar with features from other languages, they're basically just one of the ways that Flutter handles asynchronous operations by figuring out what to do in your app before an action, during the action, and after that action has finished. So if you're familiar with Android development, you can kind of think of these like async tasks. Features will come up a few times during this talk, but a really detailed look of this feature is just kind of out of the scope for this presentation. So yeah, as long as you remember before, during, and after an asynchronous action, that pretty much covers the bulk of what you need to know about features. So this method is triggered once the maps data has finished loading. So the example in this presentation is going to load the location of Google's offices around the world as a list of objects that will then be displayed as markers. Once those office locations are loaded, the map data structure of markers will get cleared, and then we'll loop through each office. Each office will then be converted into a Google Maps marker that designates the office's location, name, and address. And we can also add an action to OnTap, such as bringing up a navigation screen or just displaying additional information about a specific marker location. And then finally, we'll take each marker and add it to the global map data structure that we had cleared earlier. So back to the Google Map widget, we can set the initial camera position and zoom level. So in this case, it's just a really high level view that's centered in the middle of the Atlantic Ocean at 0, 0. And then finally, we can set the, or rather add the set of markers to be displayed into the Google Map by just assigning this data structure into the property. Cool, so next up is Flutter. Flutter is a third-party plugin that I thought was just kind of too cool to not include in this talk. The plugin is great when you want to animate icons, buttons, and other items in your app, and add some extra kick to your UI, which is always great when you're trying to sell an idea to somebody or just show off for hackathon judges. So it's worth noting that you can do some of this manually by using native widgets like Animation Builder or Transform, but it's just not really as easy, which is why the plugin has a lot of value to it. So using their animation website, rive.app, you can stage out animations that will then get converted into a vector animation file that you can export and run in your app. So overall, I think it took me like 20 minutes of a tutorial on YouTube to learn how to make this exact fading and spinning star animation, and then how to properly set up the keyframes. Luckily, once you know how to do one animation, it's really easy to take those ideas and then just make more of them even faster. So you can create things that will make your app stand out a bit. Once you have your vector animation file exported, using it is as simple as just initializing this custom flare actor widget in your app, and then assigning it the animation file that you want it to run. You'll also notice that I listed the animation title as Go in one of the properties. This is just what I called the animation in the web app before I had exported it. And then while we talked a lot about rapid prototyping for just apps, it's becoming more and more common that people need to make prototypes that consist of an app with a hardware device. So for this next section, I want to briefly touch on FlutterBlue, which is a third-party plugin that helps you communicate with Bluetooth devices using a Flutter app. So while I'm not going to go into a lot of detail here, this is an area that's worth knowing for people that do need to make an IoT prototype. So I just want to make sure that it's at least introduced. So the first thing that every Bluetooth app needs to do is scan for advertising devices. You can do this by calling start scan on a FlutterBlue instance. You can also, and probably should, set a timeout duration so that the scanning stops after a period of time. Next, you will listen for results to be returned from that scan, and then you can act on those results, like saving a particular device based off of its name or its RSSI value, which the RSSI value is just kind of like the received signal strength of a device. After saving your device, you'll probably want to connect to it using the connect method, and then you can discover the services that are being broadcast by that Bluetooth device. Depending on your setup, you may also want to loop through each of those services to do something with them in your app. One thing that you might want to do is pull down each characteristic, or essentially the piece of information that's going to be with it, from the broadcasted service. Not only can you read these characteristics, but you can also asynchronously write back to your hardware devices by using those characteristics. And then the final thing that I want to cover with FlutterBlue is that you can attach a listener to characteristics that will be notified anytime new data is pushed to a characteristic by the hardware device, allowing your apps to stay reactive when dealing with the real world. Cool. So to wrap up our introduction to Flutter, I want to talk about just one more common task that you'll run into when building out a new app, which is retrieving data from the internet and then parsing a JSON payload into Dart data objects. So this sample will go over a simple list item that pulls data from the Etsy API to display inventory amounts for each listing in a single shot, though the same idea can be carried over to countless other common scenarios and essentially anywhere that you have to deal with HTTP requests or REST APIs. So the first thing that you'll want to do is use a feature builder in your app, which you may remember is a specific component in Flutter that lets you decide which widgets to show during or after loading data. So in this case, I'm going to use a new method called future listings. This method is asynchronous and returns a future object with a type of listings, which is a custom object that represents the array of items coming from the API. This method will use the HTTP package to get the data from our API endpoint, and if that endpoint returns a 200 success code, then we'll use the JSON.decode method to convert the response into a JSON object, which will then convert into a listings custom object. So this is done from a custom object that I created earlier called listings, using some kind of Dart magic under the hood that converts a JSON map into a list of objects with this type of dynamic. Dynamic's kind of like an undefined generic. And then once you have that data from the future, you can do another conversion to switch the list of dynamic objects into another custom object, which in this case is listing without the S at the end, which is just an individual item from the earlier listings array using similar JSON conversions. So this example also sorts the list using this like simple A to B comparator operator. That's not required at all when you're trying to pull down data from an API and all that kind of stuff. But I thought it was kind of nice to include for anyone that's trying to put together an app quickly. And just because it helps make things look nice. And I feel like that's one of the most search for things on Stack Overflow in a new language is how do I sort a list? So there's the example. So after all of that, though, you can create a new list view of list tiles, just like we did earlier in the presentation. And then for the last part of this sample, if there isn't any data in the future builder, such as during the time that the data is loading, then we can just display a circular progress indicator until the results are available. So it's also good practice to handle error cases in the future builder, though I didn't in this example just to save a little bit of space and time. Cool. So for the next part of this talk, we're going to learn a little bit about Firebase and how to use it with Flutter using Google's open source plugin, which is called Flutterfire, which you can find out on GitHub. So first, let's go over the official pitch for Firebase, just to kind of get that out of the way. Firebase is an application development platform with a mission to help app developers succeed by using Firebase products. Firebase accomplishes this by taking common problems and developer tasks that occur during a product's lifecycle and making them easier to solve, be it by providing more information about your apps and their performance, or providing tools to handle complex problems like security and network connectivity when storing data. Cool. So Firebase is actually divided into these three main categories of tools, and each has its own specific goal. The first one is build, which is basically, it helps you build better apps by making complex coding processes easier, or improving app quality by helping you catch issues early and fixing them quickly, and helping you grow your apps by understanding how other people are using it and engaging with them in a meaningful way. So as you can see here, there's like 20 different products within Firebase. So while that may seem like a lot, today we're just going to take a look at a subset of all the Firebase features that are going to be the most relevant to rapid prototyping and building out apps quickly. So again, the goal here is not to overwhelm you, but rather to let you know just what's available when you need it. So before you can start diving in and using Firebase in your apps, you will need to create a new project. So you can do this at console.firebase.com and basically just type in a project name and hit next a few times to get set up into your project's console dashboard. So the next step will be linking your apps back to Firebase. So for this example, I'll only touch on the Android and iOS processes. So for Android, you will need to enter in the apps package name, which you can find in the Android manifest.xml file in your project, and then potentially the SHA-1 certificate for your signing key. You only actually need the SHA-1 certificate if you're using like Google sign-in, dynamic links, which also includes like email link sign-in, and a few other features, but we'll introduce a few of those in the next section. After that, you'll need to add some code to your build.gradle files for both the core Firebase functionality and the specific Firebase products that you want to use. You'll also be provided with a Google Services JSON file, though through the setup process that you'll just need to copy into your Flutter app. And then the iOS process is similar, if not a little bit easier. You'll basically just put in your bundle ID and then copy over a generated plist file into your app, and then install some pod files for the products that you want to use. After that's done, though, you should all be golden for using Firebase on both iOS and Android with your Flutter app. So the first feature that I want to go over is authentication. While it's not the most flashy feature, there's always that one hackathon judge that asks you about security, so you might as well just toss it in since it's honestly easy enough to use. Firebase authentication allows your users to log into your app using a username and password, a phone number, a third-party identity provider like Google or Facebook, or a few other options. So for simplicity, I'm only going to go over a few of the more commonly used authentication features. So let's go ahead and start by discussing user authentication using an email and password. A major part of the setup process occurs back in the console. So aside from adding your app to Firebase and including your Google Services JSON or plist file, you'll need to enable each type of Firebase authentication that you'll want to use from the Firebase auth section in the Firebase console. After project setup and enabling auth, you can actually go back to the code for your app. So using email and password sign-in is actually super easy. The first thing you'll want to do is register your user's email and password, which you can do by calling create user with email and password, which pretty aptly named method. And this is on the Firebase auth instance. You'll also this will also automatically log your user in. So if you want to sign a returning user in, you can use the sign in with email and password method just as easily. Yeah, so those are create and sign in. They're basically the same method name. It just depends on what exactly you want to do with them. And then next up is email link authentication. So this authentication feature takes an email address from the user and then sends them a link that they can use to sign in. Basically, this just proves that they actually have access to the email address rather than just putting in anyone's email address and then a password and then saying that that's theirs. So just like the email and password method, you will need to enable email link sign-in from the Firebase console. So this is actually an additional option under the email and password method. So you just need to activate the appropriate slider and then click that little blue save button in the corner. You'll also need to enable dynamic links in the Firebase console, as these are what's used to associate your app with the user's email via the sent link. And then you may remember from a few slides ago that enabling dynamic links also means that you need to have the SHA-1 certificate added to your app for Android in the Firebase console. So when you're ready to sign the user in, you'll need to email them a link using the send sign in with email link method while including the information for iOS or Android app packages, as well as a dynamic link for your Firebase project. If everything goes as expected, you should receive an email like the one in this screenshot that contains a sign-in link for your project. Clicking on that link should open your app on the user's device. And I should mention, you can actually customize this email as well, so it's not going to just say project dash whatever numbers. You can make this look like something that would actually be coming from your app or your company or what have you if you wanted to use this. Otherwise, the generic email is just kind of bland and meh. So cool. So after the user clicks on that email link, though, your app will immediately call the did change app lifecycle state flutter once it opens. You can check to see if the lifecycle state is resumed, and then see if there's a dynamic link associated with the opened app. If there is, then you can just go ahead and handle that use case. So generally the way that you would do this is by calling Firebase auths sign in with email and link method to retrieve a Firebase user. So again, Firebase auth is just using really simple descriptive names. So if you're ever looking to do an action with Firebase auth, you can kind of figure it out by just looking at the method names that are there. And then finally, all you have to do is update your app state data so that the UI and everything else associated with what's on the screen updates for the user being logged in. So the final auth type that I'm going to go over is Google sign-in. From my own experience, this is probably the easiest of the third-party authentication methods to use, but mainly because there's already a Google sign-in plugin that speeds up the process. So if you're interested in the detail of using other third-party identity providers, I actually recently put out a blog post on Medium that goes in a lot more detail on these options. So you can find it on my Twitter or through Googling or whatnot, or even just email me. My email will be at the end of the presentation. I can send it over. So you will first need to actually instantiate the Google sign-in object, then call the sign-in method on it. So this is a part of that Google sign-in plugin. If the user's device is able to use Google sign-in through installed SDKs or whatever, then they'll be prompted with this sign-in dialog similar to this. So this is what it looks like on Android. Actually, if you're on iOS, what this will do is it'll go out to a web browser where the user can put in their email and password, and that'll send back their credentials in the same exact way as this. It just isn't going to have this like pre-made UI that looks really nice. So after the user has selected their account, he'll be able to receive a Google sign-in object. So you can use this to call authenticate against Google's identity provider service. And then once the user is authenticated, you can retrieve their auth credentials from Firebase using the Google auth provider. Or rather, this is not from Firebase yet. This is just retrieving their credentials from Google by using their access token and ID token. The next step here is actually where you would retrieve the Firebase user using their already Google authenticated credentials. Additionally, if the user's already been previously authenticated, then you can just retrieve their Firebase user by using the current user method, which is a little bit unrelated, but it kind of needed to be talked about. Just another way to retrieve the user after they've already been signed in. Cool. So the next thing that I want to talk about are the two database options that are available on Firebase. So the first one, the real-time database, uses a simple JSON tree structure to store and access data. So this data is stored and synced between users and devices, and its main goal is to provide a back-end data storage solution without having to go through the whole tedious process of setting up your own database server, authentication scheme, a REST endpoint, and everything else that goes along with building a typical database infrastructure. So the first thing you'll need to do to use the Firebase real-time database is create this Firebase database object in your app. You can then create a reference to a specific node in the JSON tree data structure. So in this case, the node is just called messages, and it's a child of the root node. So you can actually create as many of these references as you like as well, such as this part of the code that's actually going to reference the counter node, and then it just reads the value from it once rather than continuously listening to it, and then prints out whatever that value is. And then after you have your reference, you can associate it with a listener in order to take action on any data changes as they happen. And then finally, I just want to introduce this new graphical widget from the Flutter library called Firebase Animated List. So this works like a standard list, but it'll animate as items are added or removed from it. And it works specifically with Firebase references to listen for data changes without having to tie everything together manually. If this widget doesn't quite fit your use cases, there's also going to be the Firebase list and Firebase sorted list widgets that also listen to Firebase references, but then they do different things, like they'll pre-sort items or they'll just display everything in the order that they come in. And then for reference, I just have the same exact screenshot from the first real-time database slide with the animated list. So you can kind of see how everything is working and looks in more context. So the second option, Cloud Firestore, is a database tool that allows you to group data using a document collection structure for straightforward access. It offers many of the advantages of the real-time database, such as real-time syncing, offline support, and scalability, but also supports basic queries in addition to direct data access. One thing that's important to remember here is that Cloud Firestore can be used in conjunction with real-time database, as each serves its own unique purpose within your app. So you don't need to pick just one or the other for everything in your app, but you can use both of them in the same app, depending on what you need to do and one's going to be better for whatever your situation is. So like most things in Firebase, it only takes a few lines of code to do the most common actions, like reading and writing data. By first getting an instance of the Firestore object, you can retrieve a child collection from Firestore, and then once you have that collection reference, you only need one call to add a new document to it. It's also going to be just one call to retrieve all the documents from the collection just one time. And then despite these two operations being really simple, I also wanted to just take a second to look at something that's a little bit more complicated, like listening for changes to your data. So you can do this by creating a stream builder object that listens to a specific path in Firestore and updates whenever new data comes down. So I'm not going to get too deep into what a stream builder is, but you can kind of think of these similar to like futures in Flutter. Except they're going to be activated like anytime new data is sent to them rather than just for a one-off asynchronous option. So this object can then check to see if a data snapshot is available. And if it isn't, then it can return this default UI widget. Otherwise, you can retrieve the data from that snapshot, and then using that data, you can update your app's state and UI. So in this case, we're using the length of a data snapshot to define how large a list view should be, and then displaying list tiles in that list using the actual documents that have come down. And then while we've talked a lot already about database options, sometimes you just need to store and serve user-generated content, such as images or audio files, stuff that's not just text and numbers, directly into your mobile app. So you can do this using cloud storage for Firebase. So uploads and downloads are handled by the cloud storage SDK, or rather the ones that are handled by the SDK are resumable, which makes them more resilient to changes in network connectivity. When a user's connection is disrupted during an upload, the SDK will automatically handle retrying and resuming, which can be critical when you're dealing with the kind of network conditions that you kind of get with mobile devices all the time. And then downloading content uses the same system, so it allows users to receive their data once a connection is successfully reestablished. So if a connection gets disrupted, things will just kind of pick up where they left off as soon as there is a connection again. Once the user's content is uploaded, it can be shared with other users in your app using the same SDK. And since you'll likely run into situations where only certain users should be able to see or upload specific content, you can use Firebase's security rule system along with Firebase authentication to restrict content according to your app's requirements. When you want to upload a data object cloud storage, you can just get a reference to the storage path and then create a storage upload task by calling put file or put data on your storage reference with the items that you want to upload, as well as any metadata that you want to associate with that item. You can also save a reference to that task in order to pause, resume, or cancel the action. And then downloading a file is similarly easy. So you can just specify a storage reference for that file that you want, and then just get the download URL. And then once you have that URL, you can just pull down the file using a HTTP request, which is kind of similar to what we had talked about with the Etsy list item app earlier in this talk. Nice. And then once a response is received, you can receive the information about that file and then use it in your app. And then Cloud Functions for Firebase are single-purpose functions that are executed in a secure, managed environment for your Firebase project. So they are powerful tools that let you handle complex logical operations from within Firebase, such as performing operations on your Firebase database or interacting with various other Google or external services. So these are just kind of great for handling backend logic in general for your app without having to set up this whole complicated backend system. So to kind of give you a quick example, I have this function that's already written using Node, and then it's hosted up on Firebase Functions. So what will happen is when it receives an HTTP request at whatever its designated URL is, it'll get the date and then respond with a hello message as well as the current timestamp. And then you can actually call these functions directly from Flutterfire's HTTPS callable object with an optional data map. And then you can just listen for the results asynchronously to update your app's UI. And then at the last FireConf, we actually released a new product called Extensions, which are pre-made functions that handle common tasks for developers without them having to kind of reinvent the wheel. Oops, I don't want to shake my screen here. So you can actually find these in the console, though, to see what can work in your app, And we're still kind of releasing more over time. So you can actually see that we have some that will resize images that get sent to cloud storage, or will translate text that gets written to Cloud Firestore. A few other things, they send you emails and whatnot. And yeah, there's just a couple dozen of them right now, and we're still adding a lot of them. And then since it's actually the only product that I'm going to talk about today that isn't in the Firebase build grouping, but app distribution is just kind of great for rapid prototyping when you need to work with other people on a project. So what you can do is you can upload your install file and then add either an individual or a group in the console, so that people can receive an email and then download your app without having to go through like an app marketplace or even plugging into your computer, which is kind of nice right now because people are working on hackathons and whatnot virtually. So they're not there with other people to be able to plug into computers. So it just kind of helps keep everyone involved and able to work on an app. And then the final thing that I wanted to talk about in Firebase is Firebase ML, which allows mobile developers to enhance their app's user experience by applying machine learning. So Firebase ML provides a variety of models that can run quickly from the cloud with a high level of accuracy and detail. The out-of-the-box models allow developers to recognize text, label objects, and identify landmarks. Developers can also take their custom TensorFlow models and then run them through Firebase's easy-to-use APIs. So Firebase ML is a little bit more complex than other Firebase products, but it's still not too bad. So for this example, the image and image rotation parameters are found prior to running the method. And how you retrieve an image will vary depending on the type or whatever your app needs. So you can either open something from the camera or from your gallery or wherever else you might have images. So there's actually a great sample that retrieves an image using scanner utils to get the camera stream in the Flutter Fire GitHub repo. So I'd really recommend checking that out if you want to get a lot more detail on this. And then once you have all that necessary data, you can call the process image method on your Firebase ML object to just kind of get everything started. And then we have three methods here that aren't really defined in this snippet, but they're concatenate planes, build metadata, and rotation into image rotation. So each of these are just helper methods that you can actually also find in the GitHub repo. But in short, they simply just manipulate or add the image data so that they can be analyzed properly by Firebase ML. So we've covered a lot this morning, or afternoon, I should say. So if you want to learn more about Flutter or Firebase in depth, then the top few links will give you a ton more information and resources like code labs and videos. For Flutter, I actually really highly recommend checking out that Flutter codebook that we talked about earlier. And then you can find more information about all of these features on or in Flutter Fire or in the Flutter gallery up on GitHub. So again, my name is Paul Ruiz. I'll be posting the slides for this talk up on Twitter under my account. You can find that here on this slide as well. Or you can just reach out to me directly through my work email address at ptreese@google.com if you have like fairly in-depth questions or just want to reach out for anything. Cool. So thank you.
Thanks, Paul. It was a great presentation. Let's check if there are any questions. There seems to be no question.
Okay.
Thank you for participating in the Fest Turkey agent. See you again at another event.
Okay. All right. You have a good one. Bye.